Okay, let's look at a few more pictures. Okay, this will be a shorter video, I think, and then we'll do another video with some of the actual fossils that I just happen to have at home. Not that many, most of them are in the classroom at school, but I did happen to have a small number of real fossils that we could take a look at, and I'll put under the projector. Here we can see a fossil fish. Fish are very common fossils because, again, they have that skeleton, that bone-like structure. So fossil fish are actually pretty common. Here's a fossil insect. And again, under the right situations, even insects can be fossilized. Again, if we have rapid burial and fine sediment, we can indeed get fossil insects even. Here we have what are called ripple marks, and they don't necessarily represent past life, but these kind of lines here represent that this was seafloor at one time, and we're seeing fossils of the little waves that sometimes you see in the beach. So if you go to the beach in the summer and you see those kind of like little wavy lines in the sand, that's what we're seeing here, but it's been lithified or turned into sedimentary rock. And here we have these ovals, which are some sort of nest, possibly fish, some fish nest. Hominids are fossils too. Not so much Homo sapiens, but we have other hominids or human-like animals, fossil records. You've certainly heard of Neanderthals. There's other hominids too, Australopithecus and other types too. Homo habilis and so on. So we have different human like fossils. Here are more brachiopods, and again, asymmetrical shells, often with an indentation. Here we have petrification. Out in Arizona, they have some of the best petrified wood in the world. It's protected. You're not allowed to collect it. It's actually under the National Park System. But here we had logs that were submerged in water. That water was mineral rich, and over time, the woody cell structure of the tree was replaced with minerals, most often quartz. So even though this looks like a piece of wood, it's actually largely quartz now. The woody cell structure has been replaced with quartz most of the time. It's quartz. Here's a saber-toothed cat. See those giant teeth, right? These creatures lived during the Pleistocene and during the last ice age, and then we'll talk about them separately another time. Here we have some amber coming out of a tree, and we talked about fossils being preserved in amber, insects preserved in amber. Here we're back to our trilobites again. Remember, most fossils are incomplete. It's unusual to find a whole fossil. It can happen, but it's unlikely. And usually what you find are fragments and pieces of the fossil. On these trilobites, what often happens is the heads fall off when the animal dies. And when the animal dies, it disintegrates. Also, sometimes what happens is scavengers start spreading the remains around, and then fossilization happens. So oftentimes the creature is not intact when fossilization occurs. Here's another trilobite. This is good preservation. We can see the head. There's where the eyes would be. Eye there, and here's the tail. And again, trilobites would crawl around on the seafloor and look for tasty things in the sediment. Here's another species of trilobite. There were hundreds of different species of trilobites. And trilobites, they used to be one of the dominant forms of life on Earth. Trilobites used to be in huge abundance in the ocean. Okay, so that's it for pictures. Let's take a look at some actual fossils now. So I'm going to switch to the camera, I think, and let's take a look at some actual fossils. Okay, I'm back and I've switched over to the projector. Let's take a look at some actual fossils that I happen to have. Some of them are quite common and some of them are quite unusual. Here's an actual fossil here. Okay, there is a brachiopod, and the brachiopods, again, they have a asymmetrical shell. So if I take this shell, these creatures were called bivalves and are in the same group as clams and mussels, there's a separation here between the top half and the bottom half. And if we look at the two shells, they're different. The top shell has a different shape. It extends all the way down to here. This is called the foot. This is where the brachiopod would attach to the seafloor. And then this is the other half of the shell. These creatures, clams, mussels, brachiopods, are all what are called filter feeders. And they would basically suck in seawater, filter out any nutrients, and pump the water back out. So these are called filter feeders. And that's true of modern day clams and mussels too. They're all filter feeders. So that's a brachiopod. Again, asymmetrical. We can see the top shell is very different from the bottom shell. From the top, it might not look that different, but when we look at it from the side, we can see differences in the sides, shapes of the shell. Let's see, here's another shell. Here's a fossilized gastropod or snail shell. And we can see that spiral shape. This is pretty similar to modern day snails. The snail would live inside there and carry its shell on its back, of course. We talked about fish forming fossils. Sometimes it's a little difficult to tell what your fossil is. Again, the animal gets distorted and destroyed partially before fossilization takes place. We can see on both of these fish the head are missing. So they both have no head. It's possible a scavenger maybe even ate the heads off the fish. But we can certainly see the fish scales. And here we have two fish side by side. A fish here, a fish there, and we can see those fish scales. So these are definitely fossil fish, even though the heads are not intact. Good preservation. We don't see the bones, but we can even see the scales of the fish. And I think those scales are showing up quite nicely. Here's another common fossil. Here we have an ammonite. Ammonites, again, they would have a head with tentacles coming out. They would swim in the water column. They were predators, and they would catch small creatures swimming in the water and eat them. This is a relatively small ammonite. They could be up to several feet across, the biggest of ammonites. Here's another ammonite, and this ammonite has been sliced in half on a rock saw and polished so that we could see the inside. So here we have the two halves, and if we flip them over, we can see the inside structure of the ammonite shell. And as the animal grew, it would add a section to its shell. And it kept adding a section and a section and a section and a section, and it eventually grew larger and larger and larger. So as the ammonite got bigger and bigger and bigger, it would add section and section and section. And we can see that the shell is filled with mineral deposits. We can see there's crystalline material in here, probably calcite, I'm guessing. Probably really need acid to tell for sure and see if it's calcite or quartz, but it's probably one of the two. So these chambers would be empty normally, and the animal would live in this last chamber as its shell got larger. So by slicing this in half and polishing it, we can see the internal structure of the shell and how the animal actually lived. We also talked about trilobites. And again, oftentimes when these creatures die, they fall apart. Here what we're looking at is just part of the tail of a trilobite. So we don't see the entire animal. Again, trilobites would crawl along the seafloor. They would look for food in the mud and sediments that they could eat. And here we have our tail here. And I happen to have a really large trilobite from Morocco. Let me get that. Here's a very big trilobite. I'm not even sure I could get this to fit under the projector. Let's see, I'll zoom out as far as I can. Yep, there it is. A very big trilobite. Here's my pen for size. So this is pretty large. There have been some finds bigger than this, but this is pretty big. And here we can see the head to the trilobite, the body, the tail, three-part body structure. Here we have a much smaller trilobite, and we could just see the tail of it over here. Okay, so trilobites came in a variety of different sizes. Again, they lived on the seafloor, and they would sift through the sediment. They used to be very, very common. Now they're completely extinct. But they used to be a very common creature on the seafloor. Let's look at just a few more. The next fossils I have to show you are unusual fossils. They're not common. They're relatively rare. Here's one. Might not look like much, and if you walked by it, you probably wouldn't even think much about it. It might look like an egg, but it's actually a wasp nest. Sometimes studying paleontology is very difficult because you don't really have the big picture of what you're looking at. But this is a wasp nest, actually, from a mud wasp, and it would live in the ground and make these kind of round nests. Strange fossil, unusual. Here's another unusual fossil. This is actually fossilized poop from a sea turtle, and we call this coprolite. And fossilized coprolite, or poo, is, well, obviously it's fossilized as a rock, so there's really nothing dirty or disgusting about it. But it gives us insight into the life of the animal. It gives us insight into what the animal ate. By analyzing what's inside of this, we could figure out what the diet was like of the creature. So we could figure out what the animal might have eaten from looking at coprolite or fossilized poo. Kind of strange. Here's an interesting one. This might not look like much, might be a little hard to tell what it is, but this is actually a species of lobster. And it had these paddles or flippers here. And here we could see the back of the animal here, and that resembles a modern lobster that you would get from the grocery store or a restaurant. We can see these plates that make up its back. Again, animals with hard parts, most likely to be preserved. Okay, so might not look like much, but maybe you can kind of make that out. Here would be the back of the creature. There, tiny little lobster. Here's one. You might have collected these at the beach. This is called a sea biscuit. And this would be in the water, kind of like a sea urchin. And it would have these little feathery structures here that would stand up in the water. So there's all types of fossils. Again, a lot of people think of mostly dinosaurs. But there's much more than that. Here's a kind of unique fossil. This is a fossil clam. We can see those ridges there, very typical of a clam. If I flip it over, we could see more of that clam shell. But what really makes this fossil special is the crystals that are growing inside of it. So when this fossil formed, well, we have our fossil clam, but it also acted kind of like a geode. And this was a great spot for quartz crystals to grow inside of or actually, sorry, those are calcite crystals, actually. But it acted almost like a geode and made this little pocket where a liquid could accumulate inside and form crystals. So this is actually kind of a unique fossil, not so much because of the clam, and it is fairly large, but more importantly, because of those calcite crystals that are growing on the surface. So fossils come in many different shapes and sizes and forms. As we go along, I'll show you some more real fossils, and we'll do dinosaurs in their own group. We'll look at dinosaurs in their own way, and other large mammals. But again, many fossils can be small. They don't have to be big, like a T-Rex skeleton or anything like that. All right, so those are some actual fossils, and there'll be more videos about larger animals like dinosaurs and large mammals later on. Okay, so all for now.